Hello everyone and welcome to another episode of the XGain podcast series. I'm Urania Dinu from Reino, the partner responsible for maximizing the impact of XGain. XGain is a research project that aims to bridge the digital divide between urban and rural areas by facilitating access to last-mile connectivity solutions. In today's episode, we are honored to have Tanel Järvet. Tanel is the Managing Director at CAFA Tech, and today we will have a very insightful conversation regarding digital connectivity in remote communities. Hello Tanel, and thank you for being with us today.
Good afternoon. Thank you for inviting.
Let's start by understanding your involvement in the XGain project. So, what's your role in XGain?
CAFA Tech is an Estonian robotics company, and we are contributing to this XGain project with our robotics platforms. The two combined platform, let's say the CAFA multi-robot system, we are contributing with our drones component and also our UGV ground robot components. And a little bit later I will explain how the combination would work.
It sounds like CAFA Tech plays a crucial role in the development of the XGain solution. Could you share a bit more about the use case that you lead?
We are leading the use case which planned to perform in the UK Scilly Island. This is a remote area, and the 5G connectivity is, let's say, quite constrained to the geographical conditions, and we are contributing with our multi-robot system, and we are using the both benefits of the ground robots, which can measure the agricultural parameters, let's say the soil quality, fertilizers. These sensors are onboarded to the UGV ground robot, but this ground robot is supported by the UAV, the drone, and the drone has some positive aspects comparing the ground robots, because drones can fly at the quite high altitude, and the drone can cover the much bigger area, and drone can take the photos about this area, and based on these photos the multi-robot system, or the brain, let's say the computer processing part, can send the UGV for the specific direction or the specific location to perform additional measurements. That's a big picture, the architecture.
Okay, that's very interesting. So, Scilly Islands is a key location for this use case. Why did you choose specifically this remote region, and what specific challenges of remote communities are being addressed?
The Scilly Island is quite good example of this remote island, because normally there are only the one cellular mobile base station, but there are a lot of people living in the different locations, let's say quite sparsely populated areas. So we need to solve also the problem how to provide the connectivity, the 5G connectivity extension to these people who are living quite far away from these base stations. But we fully understand also the mobile network operators' economical point of view. If there are only quite a few people living, there are no paying customers for them. But we, in this Scilly Island use case, we will demonstrate how to solve this challenge using these drone components. Because if we will elevate the 5G modem to the higher altitude, then we can provide the 5G relay or extension to all these remote locations also. That's a technological solution for this, let's say, economical problem.
That seems that you have a big mission here in this use case. You mentioned that you use a combination of both drone and ground-based robots, so that sounds very fascinating. Could you tell us a bit more about these technologies?
Yes, our ground robot, as we understand, the ground robot has much more batteries, let's say the electricity, power capacity, comparing the drones. So the ground robot has on board its mini computer, which can process this data captured by the ground robot, sensors, and also it can support the drone video image processing, all these AI-related tasks, which need much more power that it's available on board the drones, the UAV element. But UGV main task is to perform these sensing activities, because a UGV ground robots are also robotics arms, and we can take some measurements. We can take some samples from the soil to measure the soil humidity, to measure the fertilizers quantity, quality, so on. And as we are using this open platform, open computer, so based on the local needs, the specific agricultural needs, we can easily use this processor handling the data feeds coming from the different sensors. We can add much more sensors on board. We can shift it. It's a modular based approach. It's based on our stakeholders' needs, what they said during our workshops, which we performed during the XGain project first year. Now we are starting the third year, and we are aligned with the end users, let's say the customers' needs.
Mm-hmm. That's very important. You mentioned that you have this robot places some sensors in the soil, and it collects various data. Could you tell us a bit more about what kind of data do the sensors collect, and why these data are important for the farmer?
Yes. Let's say the farmers needs three main groups of data. First one, it's of course the soil quality, the fertilizers. The second one is related humidity, and based on that, farmers can decide some actions, activities. And the third group is related to pests and insects, because as we know, the pests, if the farmers can detect as early as possible these pests, then they have to use only the very minimal quantity of these chemicals to affect these pests. And based on this robot platform, we can measure and detect the pest existence, or if they are coming, the first location is started, then we can, in the early phase, we can detect this pests, inform it automatically based on the onboard computer, the AI part. We can analyze this data, and we can send the alert to the farmers. And then they can take the appropriate measurements and to handle this problem in the early phase.
So we see that these technologies can benefit farmers in various ways. It seems like the innovations we have here have broader applications. So how scalable is the solution for other remote or underserved areas?
Yes, the scalable solution, it supports the quite easy calculation based on the geographical dimensions. For example, if the 5G base station can cover like area 10 kilometers radius around the base station, then we can easily calculate the scalability. We can use this multi-robot system to relay these 5G signals. We can use them as the relay station. But regarding these measurements, looking only at the agricultural point of view, then we can easily calculate the daily processes, how many hectares, how many square kilometers have to cover by these multi-robot systems. And it's a very easy economical calculation based on the routine, how the farmers need these informations. Do they need weekly? Do they need a daily base? Then we can easily calculate the frequency to collect this data, and based on that we can easily scale up this solution for the bigger farmers, supported, for example, by 3 multi-robot systems, and for the smaller farms, maybe 1 multi-robot system can cover all the different fields.
Mm-hmm. With these advancements in place, what are the next steps for this use case?
For this use case, in 2025, next year, we will have the field tests, and currently we are adapting some technology component. We are performing the processing test to analyze which models of the computers, GPUs, are relevant for processing different tasks. Because we need a little bit different, let's say, the processing devices to handle the very complicated AI part to analyze the different pests and insects. But there are much simpler missions or tasks to handle the sensor data analyzing only the fertilizers quality. There are only the quantity-based calculations. But for the pest, very small, flying, there are much more complicated situations.
Yeah, indeed. So we really look forward to see what's next for this use case and what is going to be the positive impact that is going to have to not only to Scilly Islands, but to other regions in the European area as well.
Indeed, as we are Estonian robotics company, of course, we plan also to perform these multi-robot tests in Estonia, supporting Estonian farmers and to showcasing how they can use these high technology components, supporting their agricultural business.
So thank you, Tanel, for being with us today and for providing us so many valuable insights.
Thank you very much.
Also, thank you all for being with us today in another episode of the XGain podcast series. Till the next time, don't forget to follow us on social media and visit our website. Together, we can turn the digital divide into a digital bridge. Stay tuned.